Hey everybody, this video is just going to be a quick review. I'll actually be using my notes here just to make sure I get the main everything, because I'm not going to try to memorize like 10 videos of content. That's just crazy. Crazy, I tell you. Alright, but anyways, first thing we started with was super keys. So a super key was just any number of columns that ensure uniqueness within a table. So we have super key, which I still don't know why, that's only one word, which just confuses the heck out of me, so someone please explain that. Then we had a candidate key. Now the difference between a super key and a candidate key is that a candidate key is the least number of columns used to enforce uniqueness. Now you can have multiple candidate keys if you like a certain group, so if that's the case, you have to pick one as your primary key. The primary key is the one you select as the main key for your table. All the other ones you can assign as alternate keys, which, if that's the case, they still can be unique. You can still enforce uniqueness upon those, but they're not used as the main key within your table. Alright, what else? Alright, well then there's, that's pretty much all the ideas with finding a primary key, and then when you reference that in another table, you have what's known as a foreign key. Foreign keys reference a primary key. It's a connection. That's how you make connections between tables. If you have a user table and then you have a comments table, well, the comment is posted by a user, so you can reference that user in that comments table. And we talked a lot about that, so I'm pretty sure you guys got that pretty well. Now, this is pretty much all you got to worry about for primary keys and foreign keys. You just got to worry mainly about these two. These ones are less important about finding and figuring out. These two are essential. I'm not saying these aren't important. They're important, but really, defining a super key is kind of pointless when you know there's the candidate key. You don't have to say, okay, well, all of these define uniqueness. That's one super key. All of these define uniqueness. That's another super key. Oh, finally, we're down to the correct size for a candidate key. That's our candidate key. And then I'm check marking, by the way, just so you know what that is. And then, oh, okay, we got a total of 10 candidate keys, 5 super keys. Now let's find a good primary key. Oh, this one looks nice. We'll use that one. We'll set the rest as alternate keys. That's just complexity that is unnecessary, when it's easier just to say, oh, there's a candidate key. It's already the smallest that we need. We'll use that as our primary key. And now let's see if we have any other alternate keys. Oh, we don't have any good ones? Oh, too bad. It's fine. Who really cares? Oh, we do have some good ones. Oh, yeah, let's set those as an index and make sure they're unique, and we'll use those for some searching later on. That's an example of how you would find a primary key. You don't have to make this manual labor for like 20 hours to figure out which primary key to use. Alright? Then you reference that primary key in other tables with the foreign key. So that's why these two are the most important. Foreign and primary. Those are the two you should focus on the most and memorize, okay? The alternate candidate super key, and they're kind of important, but not as important. Alright, so let's take a look at primary and foreign. Let's clear this out for a second. Oh my god. Alright. Primary. Now there's some categories. Dude, I dusted, and now it's like, whew. Can't even breathe. There's some categories of keys that we can talk about. So the first one was surrogate and natural. So surrogate and natural keys. A surrogate key is just a random number that has no real-world value or no real-world meaning. Just like an ID, user ID, student ID, college ID, classroom ID, store ID, sale ID, record ID, song ID, picture ID, whatever you want it to be, I don't really care. As long as it's an ID and it's a surrogate key, then yay. I don't know what I just did there. But anyways, natural is something that's already naturally in the database, and you just define it as your key. Now typically when you want to use keys in your database, which you will because it's your relational database, you will pick either surrogate or natural keys, and you will use them throughout the rest of the database. You're not going to switch from surrogate and natural. You're not going to be like, oh, this one has a natural key, we'll use natural, but this one doesn't, we'll make it surrogate. That's a bad design. You should be able to enforce uniqueness by the columns that are already there, and then you can add a surrogate key if that's what you want to do. And if by any chance you cannot possibly define uniqueness without a surrogate key, you're pretty much required to use a surrogate key. But that situation should try to be avoided. But there's times when you literally cannot find a natural key that will be sufficient. So you guys kind of follow what I mean. Surrogate keys, random numbers, natural keys already in the table. Boom. Simple. Alright. Speaking of simple, we'll talk about the simple key. Alright, so we got simple, we got composite, and compound. Okay, so simple is basically a one-column key. Composite and compound are multiple column keys. We talked about those in the previous video, I believe. Yeah, so that's pretty much all the categories of keys. When you define your primary or foreign keys, you're not going to have to specify if it's a surrogate, natural, simple, composite, or compound. This is for our sake to design the best way, because, for example, do you want to use composite keys or do you want to use simple keys? That's a good question. If you decide you want to use simple keys, which, by the way, surrogate and natural is kind of thing you do throughout your entire database, you can kind of switch back and forth from simple and composite. For example, you could have a users table, and we could have a students table, a class table, and then we could have an enrollment table with the students taking certain classes. We could use I guess we could use a compound for this table, and then we could use simple for these tables. That's something you could do. But you should still use either surrogate or natural. Just pick one and use it throughout your database. Hopefully I'm not talking too fast, because I'm going pretty quickly. If I am, just let me know. I just need to calm down a couple decibels, because I'm kind of hyper. Okay. No, the other thing we talked about is foreign keys and foreign key constraints. Well, the main kind of foreign keys, constraints were on update and on delete. These protect our integrity of our database. You define these whenever you make a table. When you use the create table statement, or create, or whatever your relational database management system does to create tables, the chances are you're going to say that you have a foreign key. I'm just going to put FK for short. And then you have a constraint, and you can usually name that constraint. So you could be like blah blah blah, name it whatever, and then we could say on update or on delete. And the options were, the ones I taught you were do nothing, or basically throw an error, or we could update the children, or we could basically get rid of the value for the children. So that would be restrict, cascade, and set null. But your relational database management system might use something a little bit different, which is fine. Yeah, that's about it. Yeah, that's pretty much it. Yeah. Cool. Alright, so yeah, that's a summary of keys. So yeah, that was a ton of stuff. Compared to my other database design video, I had a video over primary keys and a video over foreign keys. Boom, done. This one I had like 10 videos. Alright, see you guys in the next video where we will be talking about something new. Sweet, see you guys then.